Roger's CV and a synopsis has already been circulated, but I will give a brief comment on that before he starts. After the lecture, there will be time for questions, both in the room and for those online. So I will try to put on. Before I forget, the next meeting will be here again and online, and that's on Thursday, the 23rd of November, where John Konevsky will be talking about Simon Peter's industrial tour in 1799 and his insights into technological change to the important period of the Industrial Revolution. So that's the next one. But for this one, talked by Professor Roger Burt. Now, I've known the name Roger Burt for many years because in terms of mining history, you don't have to speak very far on your Google searches before the name Roger Burt comes up. He's emeritus professor of mining history at the University of Exeter and is a well-known expert on the history and technology of metalliferous mining. He is a past president of the American Mining History Association and the International Mining History Congress. He has published numerous books and articles on mining history in the UK and overseas. His forthcoming book on mining during the early 20th century is to be published next year, and we'll discuss many of the issues raised in this particular lecture. Diamond drilling was one of the most important yet under-researched mechanical technologies to be introduced. A relatively simple arrangement designed on a principle first explored by the ancient Greeks, who used round and work by rotation rather than impact to cut through rock and extract an intact core of the ground through which it passed. It provided the first opportunity for exploration geologists and miners to see into the underlying geological strata without the costly and time-consuming process of thinking man-sized shafts tunnels. It proved critical to the discovery and development of the world's non-surface exposing mineral deposits, such as the Great Minnesota Iron Range, and thus facilitated the great outpouring of metalliferous minerals that has supplied world industrialization. Later, it became the method of discovery and producing science, and today it provides the base technology for fracking. As we begin the exploration of the Moon, Mars, and the planets, and asteroids around us, it provides so you all know what Roger's going to be talking about now. So on that basis, I think it's certainly not. Well, we can all go home. So hopefully I haven't stolen the thunder too much. Well, I shouldn't have written it down. There you go. So that's a summary of what we're going to get, but we'll get a lot more detail on that. So at that point, I'll hand over.
Thank you very much. Well, thank you for coming out. Thursday night. Shows real commitment, all I can say. My starting point is at the beginning, and is a criticism of God. The thing about God was, when he created the world, he was very messy. He threw the ores of metal around all over the place. He might quite conveniently put it in big lumps and so that he doesn't find it and see it from the surface. But in fact, it's spread around everywhere in thick sections, finely diffused sections, sections that constantly change. You never know where the stuff is. See, you've got no idea how far it is going to maintain those quantities as you begin to go underground. And this becomes a problem, a big problem, really from the 19th century. Because until the 19th century, most of the demand for metals could be met by outcropping metals. Metals that could be found outcropping on the surface, or metals that have been weathered away from the surface and deposited by hydraulics in streams and so on. By the middle of the 19th century, there's a problem. They're needing to look at the they know there are other deposits that are substantial in size, but they don't really know what they are. You've got to start to look into the earth to try and find where things are. This becomes a problem. How do you do this? It becomes a particular problem as the available geological resources begin to become more and more. The whole story of life is less and less and less Pass my words, less and less massive deposit. You start off by being able to get hold of large amounts of ore, but over time they get taken up, and you start looking for more and more marginal deposits, particularly very low grade deposits. If you're going to work very low grade deposits, you have to invest a lot of money. If you're going to invest a lot of money, you have to know how you have heard recently about the development of down in Devon, down near Plymouth. It was a very low grade tin and tungsten deposit. It was going to be very difficult. So before we start, they have to have a very, very good idea of what was in there, what depth the mineral was, what the distribution to the surrounding rock, what the quality was. They had to be able to see this stuff. And where we are? Do I just click it? We've got this thing on the screen. Before. The standard way of doing that, you still got the thing on the screen. Yeah. Okay, so that one too. There we go. Lovely. Don't leave the meeting. It's the amount of people. Aha, there we go. Right. Should be okay. Turn around. And what we're doing is one using mobile, they dig a hollow tube around the edge of the continent, the diamond that and they drill down the depth, and as they drill through the rock, they produce this form. A form is left inside the rock, and they can drill their gap and examine the top, and they can see there's no pin in the step. On the other hand, they're picking up from the step, and they're picking up where it comes from the step. I wouldn't like that. Landing out forward, they can put 5 things to the next step of fun. Working with them. Sorry. It's me. So you can have very, very large ones these days. You should actually use it to drill quite a size of itself. You can use it for a whole range of activities, for oil production. It's not used for oil production. It's different sort of thing. It's used for oil production, but it's very much used for oil exploration. This can be used also for searching for people underground. Very small stuff. another moment. And the same technology, when we put something down, find out what we can advance it. So you find that the looking the substrate of whatever it's exactly the same now as it is on the people that it's exactly the same that we're using on now. Where does this come from? The first diamond the shot. We know where this was not the patent technology in 1863. But it's almost certain that the father, George Augustus the Shot, who was an astonishing what he worked for astronomical the Rolex looked like Timex in terms of much in much place, with enormously complex systems in it. And he was one of the people involved in the development of the tourbillon escape, a very, very complex system that enabled watching to the sun he also worked, and is particularly well known amongst on the pantograph reduction milling machine, which allowed for the and was seen at the time to be a major step for the Swiss watchmaking industry, that it could really standardise the production of watches. This man is a mechanical genius, but he's not himself going to involve himself in applying technology. Where did he get the idea? He gets the idea, so we're told, from a knowledge from the ancient Greeks, and indeed before then, used this idea of spinning with hard stones set to the end of the world, clear a hole in rock. And he thinks that this would be a way for it to use for modern tools. He's not interested in applying this. His son is. His son works as an engineer and has been done in the construction coming out of it. Well, this is the design that they come up with. You see it was exactly the same reflected in those earlier pictures. It's a hollow cylinder, and he has got stones all year. And these stones are not just stones that the Greeks would have had, but are black diamonds. He needs to have something that is very, very hard. It doesn't have to be sharp, but it has to be very, very hard. And it's worked through a system of producing fin. And the way in which the diamonds are located, and they are set by hand at the end of the like how they've been by hand, I don't know. I should now say that I'm an economic historian and a mining historian, and I'm interested in the impact of these things on that subject. I've not been interested in an enormous amount of mechanical data that is often given for this stuff and a lot of the other machines that I've shown you. There's a whole subject there that is completely unexplored. So he's arranging the black lines around it, left by hand. You can use them energy system, but you can also use it just drilling a hole without a core coming out. You can use it. And one of the problems with researching this kind of tactic is knowing what kind of machine you're actually dealing with, or how they are actually applying it. Are they applying it to extract core, or are they on this occasion simply applying it with one of these to drill a shot hole? All of this represents a major change in an approach to technology. Until this point, if you wanted to drill, you use reciprocating motion. Miners forever have hit chisels, turn the chisel, hit chisels, batch it, batch it, batch it, batch it, batch it. And the same thing applied when they were drilling down. You would have impact machines that thump on the top of the drill bit to push it down the level. This is a real break away from reciprocal hammering to rotational wearing. It's conceptually an entirely different way of doing it. And the next. Rudolf, his son, is engaged to work on the Mont Cenis tunnel, which is a tunnel that goes under the Alps, the first big long tunnel. It's 8 miles long. And normally when you were drilling a tunnel with that doing, you would take a series of paths along the path. And you have people driving from different. So you have 8 different places. You couldn't do that in the end. You could only start with 6 for you to be able to get. You had to just go from one end to the other. This is in the 1850s. The kinds of progress that you're making with people driving home from within 40 years, you simply haven't got things of progress. So there's a big demand to produce different kinds of drilling machines. And this is a time when a number of people are getting into the whole idea of automating drilling, not least of whom was Trevithick early in the century. And all sorts of different designs are produced. The shot introduces his concept of the core drill to drive the hole. If we look at the next one, you see this is one of the machines. This is another device produced by Canadian, which is work. Railway tunnels are a great place to introduce this kind of technology compared with a mine. A mine is is an irregular space. It's a narrow space. It's difficult to use without a railway tunnel is brilliant. It's a big space. You've got rails from. You can bring things up very easily. It's much easier to develop this technology in a railway tunnel than it is in a mine. And one of the themes of the 19th century is more and more mining technology, improvements in mining technology, comes out of railway tunnel and railway engineering. They're the guys who are really pushing it. They're the guys with the money to push it. They're the guys with the need to make the speed of innovation in a way that the miners didn't. And again, here in the corner, and the question is how rapidly do they spread elsewhere? This was in the 1860s. You've got this idea, it's working. It's not a great idea. It's not used to drive the Mont Cenis tunnel. There are other machines that produce the shot holes much more effectively than that. This is a novel idea, doing something different and using it for skiing into the rock. Now, I'm a typical Englishman, and my command of foreign languages is limited. And indeed, if you look at mining history as it developed in this country, it's obsessed with Britain and the Anglo world. We know far more, I'm not far more familiar with Burra Burra in Australia and Deadwood in America than I am with Brittany in France because of those language constraints we look for. So I'm going on in this lecture to really focus on the uptake of this machinery in America and in Britain. The question is, what am I missing by not having easy access to French and German? The limited kind of qualitative data suggests not much. But they did develop these machines, and you can see some of these, the German ones, but they didn't apply them on any massive scale. And perhaps one of the reasons for that, for their dilatoriness compared with the Americans, is the Americans had a lot of new minerals to discover. But whereas in well-established Europe, by and large, we knew where the coal was, we knew where the metals were, and we had a much greater grip on it. But the real challenge is in America and in Australia and other places. And again, wandering around in different libraries, I found all sorts of different plans of drilling machines that were in other European countries. This was in Czechoslovakia in Central Europe. They were obviously using in the 1870s, but I'm not familiar with them at all. I have no idea what an impact they made. I'm just putting them in as an illustration that this technology escapes from Switzerland, which is our Swiss engineers of the shops, into the rest of Europe. And again, there's something else on here as well. If we look across at America, they pick up on the idea very quickly. And the first machines are taken up by Severance and Holt, an engineering company in the 1860s. And they take out a lease on the Le Shot's patent in 1863. There's also a suggestion that the display of the Le Shot machines at the Paris exhibition of 1867 also spread the knowledge of them much more widely. And what they need in America, particularly, is mobility. And this is a pretty important example. Again, this is the fact that the shot machine, this is what is patented, this is what they've got the lease for. It's a fairly static thing, the boiler, with the thing adapted to it, attached to it, and here they've simply put wheels on it in the same way to turn it into a steam train. So they can drag it around, and then they can start training it. Some of the early drill things were gas pipes, but they could simply mount a bit on the end of them, and then drill the gas pipe. It had to be cheap, it had to be simple, it had to be available. This is a small, unsophisticated machine, but it's doing a very, very important job. And the next. These machines become more and more sophisticated as Severance and Holt work on them, and by the 1870s they are able to mount all sorts of different drill bits, because it's not simply a question of drilling vertically. And I'll come back in a moment. And a minute. By the 1870s, very quickly, these are going to they're being used all over the West, and they are also being used in foreign. Some of the only use of them is in developing quarries in New England, and also in Pittsburgh. So in other words, they're looking both for vertical arranged and also horizontally arranged because of stone or salt. So the uptake is very, very popular now. By the 1870s, these are being used everywhere. One of the new companies to come in to produce these machines is the Sullivan Company, the Sullivan Machinery Company, originally of New Hampshire in the early 1870s. By the end of the 1870s, both Severance and Holt and Sullivan had moved from and and they moved into San Francisco. And that move in itself represents a very interesting in American machine manufacturing. But before, during the American Civil War, the manufacturing base of America was young. But after the Civil War, this very rapid movement to the west, across the plains, into the Northwest, not just going from the east to the west, but also from California, moving east through the Rocky Mountains into Colorado. The new center of machine manufacture for mining is no longer in the blue, which is a headquarters of the company. There is also the development of manufacturing in Chicago, and you see the Bullock Manufacturing Company producing their own machines. These machines can usually be driven vertically or at an angle, and they would want to drive multiple wherever they might find them. These are not very easy to use for exploration in the sense that the other ones could be easily dragged around. And what you begin to see is a change, a sort of separation in the design of lightweight, relatively shallow exploration, and then much heavier weight, deeper machines for looking for proving deposits once you've found them. There's all sorts of information for those who want to look further into it about the design of these machines, the speed with which they will go through rock, the amount of labour support they had, the way in which they operate and call the rods out, and so on and so on. I have some of it in other places, but I'm not to hand at the moment. And the next. These machines become more and more sophisticated. This is another one of the cylinder machines. And by the beginning of the 20th century, they were having really quite a lot of and being used to explore down to several thousand feet in depth. By the early 20th century, their use, for example, of the Rand was going down 5,000 feet. But as early as the 1870s, they are able to go down over 1,000 feet, commonly down many hundreds of feet. And the next. What I've just been showing are the deep exploration machines. These small, lightweight, portable machines continue to be heavily used throughout the 19th century and well into the 20th century, well into the late 20th. If you don't have to go deep, if all you're trying to do is to 100 feet, they are perfect. And okay. As well as the big surface machines, we also see the increasing use of diamond drills underground. And this gives you an example. If you're looking for new minerals, I'll come back to this later, but let me install this at the moment. In Cornwall, in the early 20th century, there were a lot of old mines that were running out of minerals and growing precarious economic. They needed to find more minerals. If you want to look and find new minerals, you can obviously go off to a different place and look for minerals there. But practice has shown that you usually find more new minerals immediately adjacent to the workings that you're currently working in, rather than new workings. The more like So how do you do that? Well, what you can do is you can drill at the surface. But one of the problems with drilling at the surface, is that the deposits are often vertically arranged or some slight. So you can drill here, you can drill there, but you miss them in between. So much better to drill horizontally underground. And there's a kind of a race to start to drive horizontally underground to explore the surrounding land before the mines fill up with water. Once they filled up with water, it'd be very expensive to drain them, put fuel down to explorers by the In fact, one of the things that these drills are very important for, and I think it has to be stressed, is they're very good for finding new stuff, but they're equally important for finding that there isn't any stuff. Because what miners do is that if they're not drilling, they have to drive a shaft down, or they have to drive a level. And that's very expensive. You've got to employ a lot of people, a lot of stuff. Yes, you can walk along, and if you find things, you can examine them by eye. You get a good idea of what's going on, better than you will with a diamond drill. But if you drive a level, and there's nothing at the end of it, that's gone. There's no return from that. It's completely wasted. So the importance of these devices is not just finding new material, but finding that there isn't any material and save you the cost of doing that. And that, looping back to what I was saying at the beginning, is very important when you're getting into the late 19th century and they're having to go deeper for lower quality products. Before they invest a lot of money, they need to know what that they do. And you see a lot of these very simple machines. Some of them, coming up the next, are even hand-driven. Very slow, very tedious, but you can have some effect over relatively short. If you want to see what's behind the wall, you can drive it outside. You can put it pointing to it by using a manual. And again, they're mainly pneumatically operated, but they could be operated by hand. One of the issues is that you have to blow the debris out of the hole, and that's why they're being constantly flushed with water. And the next. In Britain, the uptake of the machine is slower than in America, but nevertheless, far from. And the man who makes the breakthrough here is a man called Frederick Beaumont, captain, later major, later Colonel Beaumont, who was the younger son of the Blackett Beaumont family that owned extensive estates in the north of England and dominated the whole Weardale lead district and the area of that. He was not going to inherit the estates, that's why they sent him off to the army, standard thing for young son. But he was at the 1867 exhibition, and he saw the Shops machine being worked there, and he decided to take up a patent in England, and he established the Diamond Drilling Company. So he saw that the shop machine in Paris in 1867. He designed a new machine, an improvement of the first one, with a man called C.J. Appleby, a railway engineer. I don't know whether any of you have any knowledge. And he Beaumont transferred his rights to the machine manufacturing company, and which undertook the first drilling contract in 1870-1871. Rights were passed on again in 1872 to the Diamond Rock Pouring Company, which was a company with significant investment, and was supported by a number of leading geologists who saw the importance of this machine, not simply for the mining industry, but for the emerging science of geology. But this was the way that they could themselves begin to explore strata depth. Anyway, the Diamond Rock Pouring Company then begins to do a whole lot of activity across things during the period after 1870. There was extensive drilling in the north of England, and it was due to with a hole in 1871. And this is a classic example of the geology that there's going to be a coal field because of the base itself. It's here, it must pass over there. And they were one of the first to drill a hole to prove the existence of the coal field at that depth. This used these two little bits of the core from the home level in Weardale, Beaumont's home area of it, are really quite remarkable because I've never come across any examples of remaining core anywhere, and these are in someone's personal collection. It's just got this little thing out of nowhere that represents the early use of these devices. This machine on the left here is one of Beaumont's later machines. It's difficult to find illustrations of all of these machines. Some of these machines are used for mining exploration, but they become particularly useful for looking for water. But they're used extensively for drilling for drilling. In London, they followed up on earlier maintenance practices, made on transfer impact holes, by drilling over 1,000 feet into the underlying shoals and drain structure to secure pure water supply for the Mira company brewery in Tottenham Court Road and for Man's company in the Mile End Road. They're going down very deep in the London area into the underlying source to raise pure water for a brewing company. So it's not just mining, it's geological exploration, and it's also used for other industrial processes. For example, they drill holes to help provide water for, I think it Bill's Ironworks, one major ironworks in the north of England, to supplement the water resources that they had from surface rain. So again, by the end of the 1870s, certainly the 1880s, this technology is becoming and making a big difference to a whole range of industrialization. And again, this goes on through into the 20th century, and you can find the remains of lots of these diamond drills all over. One of them it's a long way from so you come across these vast structures of machinery. And these are some drilling rigs that they just got all lying around. Very simple, they're only shallow. What they're interested in simply looking for movement of underneath the base of so there's something required like that. You can find some other bits of stuff lying around on the surface, certainly in America, and occasionally underground. Museums often record all of this. This is in Nevada. I have a mining hall of fame in Leadville, Nevada, and the area before that is important. This section here, and this one is in Minneapolis, Minnesota, in the World Mining Museum. We've got lots of this stuff. And the next. Two things here. Another kind of drill in World Mining And I put this in really, this is a machine drill, a diamond drill, being used underground in Gibor mine in Cornwall. And I put it in really heavily from the work that I was doing simply on diamond drill into recently working on mining in Cornwall in the early 20th century. Because the diamond drill becomes critical in some developments, critical for some people who use it very successfully, and critical for some people who didn't use it and lose an awful lot of money. There were three big mines developing in Cornwall in the 1920s, 1930s. One is East Pool and Agar. The other one is Gibor, and the other one is South Crofty. East Pool and Agar, the Cornish get very irritated about this because they like to think all things come from Cornwall and Cornish people. In fact, all of these mines, the only ones in Cornwall that were successful, were run by three blokes from Surrey. Their gift was to really promote companies and to find Cornishmen who hadn't emigrated and still knew what, or who had emigrated and then come back having acquired technological knowledge in other places. In South Crofty, in East Pool and Agar, the man who owned the place, a man called Charles Morey, who was immensely experienced in mining in Australia and China and goodness knows all over the place, he introduced diamond drills underground for exploration and almost immediately found a massive new deposit immediately next to the deposits that had been worked in recent years. And it became a phenomenon in Cornwall in the around about the First World War period. Really reinvigorated the belief that there was still a lot of tin underground, and made a big difference to the whole economics of that operation. By the end of the 1920s, however, there were two other prospects. The Great Gold Coast mine, which had been producing vast amounts of tin and copper for generation, was really running out. And it needed to be completely reorganised as a mine. So they decided they had to look for minerals in a different place, away from the existing site. They dismantled their existing site, moved it about 5 or 6 miles away, and sank a great big new shaft, the Gold Coast new shaft, predicting that it would go down and it would meet the granite at about 1,500 feet. And then when they win the granite, they will discover the lost lodes that they had previously worked in the old working. They sank this shaft and they didn't find it. They sank it and they didn't find it. They sank it again. They borrowed money to find it. And finally, they didn't find anything. Occasionally, they had some horizontal drills go out and find small amounts of stuff. But they never found what they were looking for, because they put it in the wrong place and they hadn't drilled it properly before it started. Lost a tremendous amount of money, virtually the nail in the coffin of the Gold Coast. Equally, however, that's been true, but just along the way from there, East Pool and Agar also sunk another deep shaft in the gold was working. They should have known better, and they also didn't find what they were looking for, and that also proved the case. So you can see this technology, very, very simple mechanical technology, but a big intellectual step forward at the time, the movement of the rotary drilling, having a tremendous effect on the way in which minerals are found and the way in which mines were developed. And all of that was absolutely critical to the emergence of our industrial economy. Because it was only through the great electricity, copper, tin, iron, facilitated by the whole concept of industrial global. Okay, what I was going to do is go on and talk about other kinds of drilling to put this in perspective. One of the things I should say that downhole drilling in for oil wells also uses diamond pit drill bits. They're not producing core, they're just producing, they're just cutting through the rock. And really to say to you that this is the whole issue of mechanised drilling is one that no one has ever really looked at, one of the different kinds of drills and the different ways in which they help them. Thanks very much.
Okay, we've got some start with people online trying to either put a hand up or any questions from the group.
How did you lubricate the bottom of the drill? Was it necessary to lubricate it?
I'll repeat the question for people online.
Yes.
The question is how do you the drill box?
I think that one needs to be because it got stuck out and then between we start almost the main problem is how do you replace it? Because every time that's gone out, you've got to find it. And then it's fine working out the girls that the other is fine. And that's they typically do. But when we use the tools for development when they're getting bigger, they're also getting a lot smarter. Because one of the problems I don't really find is if I ever try and put up a shelf, I start to drill a hole, and it's a hard bit in the creek and it goes off to the side. And that happens if you're going down 1,000 feet in a mine, in a drilling operation or more. As it hits different strata, it's likely to move off for some flexibility. You're quite right to go up in the or to go off to the side. And there are interesting little bits of technology developed. One was to effectively get a bottle or container and fill it up with jelly, and then lower it down the hole and let it set, and then put it up. And if the bottle was going to use the name, then you know you've gone wrong. All this kind of that's one of the great things. And of course, if we're looking at the one thing I haven't looked at, I'd love to look, is what about the technology of fracking? Because that's remarkable. Now we drill a hole, not a core hole, but a hole, and then we turn it round and we go outside it. They can do that in one thing. They can do that from the going. And then when you put out the fire, you frack the rock in the sun. So this technology that is emerging during this period, this simple stuff with people with gas lights, like that, goes on to have enormous implications, not only for mineral production, not only for metal production, but for the whole spectrum of exploitation of mineral resources. There is a big expansion of diamond production during the 1880s, certainly coming from South Africa. I think before that they were coming from the Middle East or something, I don't know. But they were rough diamonds, they are not cut diamonds, and there doesn't appear. I mean, when it first is introduced, if you're looking at the newspapers reporting on the people saying, well, isn't this terribly expensive? You're talking about diamonds. At the end of the drill, the people say, no, we're not talking about diamonds that your wife has, we're talking about black black diamonds, and they're fairly plentiful, and they're not expensive. And that they're not being expensive is pretty. I understand it's still diamonds, because there are a lot of this low grade stuff is produced. You might well actually go and buy a diamond drill. I went into B&Q and I bought one of these comical things. I wanted to drill a hole in a tile, and I just put it in my Black and Decker, and you could see the diamonds glistening around the edge, and it went through and took a little claw out, made a nice hole in this tile very easily. Equally, I've got a cutter attached to my grinding thing, very thin, with diamonds around the edge. And if I want to cut tiles, to lay tiles on the floor, I use that to cut it with. This sort of principle of using diamonds is an entirely new one in the 1860s. It has become ubiquitous for all forms of customer asking for that. Yeah. 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 And how they get worn away. Don't know. I honestly don't know. I suspect that all diamonds are hard, but they might have different fracture capacities. I don't know. Yeah, I genuinely don't know about whether they now can make artificial diamond sufficiently cheaply. I suspect that possibly they can, but I don't know. I assume so. Yeah. But you always know when somebody who is taking radio is trying to polish the steam off the glass in your bathroom with the back of her hand and her engagement thing. They just put crosses on it. Or it might be. I think it's probably quite likely whether his application of diamonds was because of his use of precious stones in watches. But I don't think they're diamonds, are they? Aren't they rubies? Yes, because they self-lubricate somehow or another. So he clearly had an interest in stone. That was related to his work. I think geological is very, very critical in this whole process. But he just has this idea of doing something totally different. But all drilling before that had been reciprocal. All these things that went down the hole were reciprocal. And this is a guy saying, why don't we do something different? Spin it. And in fact, that becomes really part of the whole mechanical revolution of the 19th century, where everything starts to spin in a way that was not done before. I would assume that they also use the sort of finding chemicals. Coal fields. Yeah. I mean, basically what I've done with this article is really scratch the surface of saying, here's something very important we don't know. And it was important just who it was and what was happening. But there's a whole area behind it all of the people involved, where it was used, what the effect was, what was discovered. When I started off on this, I said to somebody I met at a conference, who was the person who developed the core drilling process? Oh, well, it was Paul Longyear. Definitely Paul Longyear. Paul Longyear was an American who developed, using drills to develop the great iron field. In the 1890s. Okay, that was what I thought was the story. We all believed that was 30 years before that. But all sorts of things. The Red Bought Longyear came along. Nothing was done. It was all going on. All the Bought Longyear ever did was to develop slightly better machines and use a more expensive one. And I like that. I like that kind of thing where there is a view and then we look at it. So we never really ask this question. We need to look behind it. And then when you look behind it, you know, there's a new thing. So thank you. Good. Thank you. Oh, I'm sorry. Good. Whatever the Americans are doing, whatever the
Well, thanks everyone for coming, and I shall end the meeting.